In this problem, we're given that the sine of alpha equals 4/5, and alpha is in the second quadrant, and the sine of beta equals negative 2 over the square root of 5. Beta is in the third quadrant. We need to find the cosine of alpha, the cosine of beta, the cosine of alpha plus beta, and the sine of alpha plus beta. So let's start by finding the cosine of alpha. Alpha is in the second quadrant. We can draw a little picture representing this situation. We know that the sine of alpha equals 4 over 5, which by definition is b over r. So the value of b, or the y-coordinate, is 4, and the r is 5. So I'm going to draw that situation here where we have the point A, comma, 4 labeled with this radius of 5, and there's your angle alpha. We can use the fact that r squared equals a squared plus b squared to find the value of a. 25 equals a squared plus 16. So a squared is 25 minus 16, or 9. A is going to be negative 3 because I'm in the second quadrant where we're at the negative x-axis. So we have this part is 4 and that part is of the little triangle is 3, but the value of a is negative 3. Therefore, the cosine of alpha is going to be, remember, a over r, so that's negative 3 over 5. Now what I want to do is find the cosine of beta. To find the cosine of beta, I recognize first that the sine of beta is negative 2 over the square root of 5. Remember, that's b over r. Remember also that beta is between pi and 3 pi over 2, so beta is in quadrant 3. If I draw a little picture representing this situation, I have my angle beta swinging around. The y-coordinate of this situation is going to be negative 2, and the x-coordinate is unknown. The distance from the origin to this point is given to be square root of 5. So to find the value of a, I use the fact that r squared, square root of 5 squared, equals a squared plus b squared. So 5 equals a squared plus 4. A squared equals 1. A is going to be negative 1. Why? Because the angle beta is in the third quadrant, so I'm at the negative x-axis. That means that the cosine of beta, which is defined as a over r, is negative 1 over the square root of 5, or negative root 5 over 5. Now I can find the cosine of alpha plus beta. The cosine of alpha plus beta, recall, is the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. We've been stating it as the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. We know the values of these four expressions. The cosine of alpha was found in part A to be equal to negative 3/5. The cosine of beta was found in part B to be equal to negative root 5 over 5. Minus sine of alpha was given to be equal to 4/5. Sine of beta was given to be negative 2 root 5 over 5. So I have negative and the negative is a positive. So I have 3 root 5 over 25, negative and a negative, plus 8 root 5 over 25, which gives me 11 root 5 over 25. Now, what we need to do is find the sine of alpha plus beta. to find the sine of alpha plus beta, we recognize that the formula for the sine of alpha plus beta is the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. We know the sine of alpha was given to be 4/5. The cosine of beta was found in part B to be negative root 5 over 5, plus cosine of alpha was found in part A to equal negative 3/5. Sine of beta was given to be negative 2 root 5 over 5. So just a little bit of simplifying. Negative 4 root 5 over 25. Two negatives make a positive, so plus 6 root 5 over 25, and we get 2 root 5 over 25 is our exact result.